Welcome to MyProjectBazaar.com. Our product title is Predictive Direct Power Control of DFIG generator under unbalanced grid voltage conditions for power quality improvements. Now we are going to discuss about our product abstract. This paper proposes a new control strategy of doubly fed induction generators DFIGs under unbalanced grid voltage conditions. The proposed controller include a model predictive direct power controller method and a power compensation scheme. In MPDPC, the approximate voltage vector is selected according to an optimization cost function. Hence, the instance active and reactive power are regulated directly in the stationary reference frame without the requirement of coordination transformation. The PI regulator switching tables and PWM modulators. In addition, the behavior of DFIG under unbalanced grid voltage in the investigated next the power compensation scheme without the extracting negative stator current sequence is developed by combining the proposed MPDPC strategies. The power compensation scheme destroyed currents injected into the power grid by the DFIG can be eliminated effectively. There are other improved control strategies worth being mentioned for the predictive current controller approach was presented the obtained rapid dynamic response. In the steady growth of distribution generator units connected, the unity grid power quality has become a major concern. In the destroyed network concern with the wind turbine system could be the damaged because oscillate the electromagnetic torque, and the main grid could be the polluted due to the destroyed stator current. The wind turbine might disconnect from the network to the product terminations. The paper organized follow the system. The DFC proposed sections behaviors of DFIG under the unbalanced grid voltage conditions and investigation of the papers. Now we are going to discuss about our product flow diagram. So we are giving the input for the DC voltage. The steady growth of the distribution generator DG units connected the utility grid power quality has been the major concern. In distorted networks conditions, the wind turbine systems and the DFIG. The DFIG, the direct torque controller DTC and DPC direct power controller were proposed in the reduce the speed and the power controller. The main we are using the VC algorithms. Later the improved DTC and DPC strategies utilized the controller DFIG under the unbalanced grid voltage conditions. The large power ripples due to the use hyper-stress controller and the predictive switching table series performance of the system controller. There are also other improved control strategies with being the mentioned. For example, predictive controller approach was presented obtained the rapid dynamic response. The algorithm was relatively complex, not easy to implement. The sliding mode controller SMC is employed. The controller DFIG is the fluently the torque and reactive power addressed without considering the power quality improvement stator current. An improved system configuration is proposed. The series grid side converter is required, which will increase the system cost. To become the drawback mentioned the above and enhance the controller flexibility, DFIG's paper proposed the model predictive direct power controller. The DFIG based wind turbine power system considered in this works The motor is connected, DC motor is connected into the DFIG, the gearbox with increased torque and lower speed. For the DFIG, the stator is directly connected to the grid, while the rotor is fed to the back-to-back power converters. The proposed controller consists of two blocks. The first one, the MPDPC torque, controlling the stator active and reactive power directly. The second block produces the power reference to ideal with the problem under grid voltage unbalanced. Now we are going to discuss about our product running procedure. So this is our project main functions. So this is a block, the simulation block. We are developed by the MATLAB 9 version, and then the simulating tool. So this is a simulating tool software. So this is our block for the wind turbine for DFIG-Bazaar model. So we are giving the input for 120 kilo voltage, and then we are using the grid, and then the output wind turbine to be fed induction generators. So this is a grid voltage output, and now we are using the 3 level of the grid, 20 kilometers line, and then B120 kilowatt, and then B25 kilo voltage, and then 10 kilometer line for the B575 voltage. So we are using the 3 level of grid, and then fault detections and the plant for the faulty detections, and then grounding transformations we are using. Now we are going to running the models. So our main objective for the how we are reduce the real and react power transient stability. So transmission power stability, how we are decrease the level. So this is our process output for the real power. So we are getting the power transient, real power transient stability is approx almost 18 some range. So we are how we have reduced the range of so 10 up to 15 18 is a normal level of the power transient stability.